Okay, so here are some actual fairly simple, straightforward example problems involving Ohm's law. Remember, Ohm's law is V equals IR. V voltage, I or potential difference, whatever, I'll call voltage. I is current, R is resistance. Remember, V is in volts, current is in amps or A, resistance is in ohms. Omega. Like a horseshoe. Anybody like Shaquille O'Neal, they've maybe seen him throw up the horns before. You can look that up yourself if you'd like. So number one is an example from an old book. I don't think it's from the purple book, the Holt book. I think it's from something else. So if you ever wonder why an iron, the press out clothes, to iron clothes, gets hot, it's due to the resistance. So that's what this is talking about. It mentions that the current is 6.4 amps and the voltage source coming from an outlet is 120 volts and wants to know the resistance. Okay, so V equals IR. That means R is equal to V divided by I. Voltage is 120 volts. The current is 6.4 amps. So that's 120 divided by 6.4. That gets us 18.75. Now I'm going to go with two significant figures. Remember, a lot of times if these zeros aren't marked, I count them, especially when they come from books. But this has 2, that has 2 or 3. We're going to go with the least amount. That's 2. That's 19 ohms. I tend to draw this pretty poorly all the time. Okay? Truth is, most of these problems are like this. They're very straightforward and simple. There's no series or parallel here at all. There's just some terminology that might seem weird, but as long as you know the units, you should be able to get things right. Like if I don't read any of this and I see ohms, that's resistance, volts, voltage. Okay? And it wants to find the current. So if I look up here, V equals IR, that means I divided each side by R, V divided by R. Oh, 24 volts this time. 24 volts divided by the 12 ohms. And all you need to do to know is if you have these units, volts and ohms, our result should be amps. So that's 2.0 amps. 24 divided by 12. Next one is find the resistance. We're finding R. That's V divided by I, once again. All right, and our volts in this case is 12 volts. It could be like a 12-volt battery. Okay, and that's where we're getting this from. And our amps, you can see, are pretty small compared to up here. Okay, so there's going to be a lot of resistance if you have a very small current. Okay, now technically that's one significant figure, so technically we should only have one at the end, so it's 200 ohms. Okay. V equals IR. This one's asking, find the applied voltage of a current that draws. You're like, what's draws? Okay, it's all right. This is 0.2, so that's the current. This is the resistance because it's ohms. And you just multiply. 0.2 amperes times 4,800 ohms. 0.2, it's a fifth, right? A fifth of this. So it should be what, 900? No. 950, is that right? 0.2 times 4,800, 960. 960 volts. Okay? And you can just keep doing that all the way down. All right? You come down here, it's like a series has this much of total resistance. Okay, it's just the resistance. That's fine. That word total might ring a bell if you watched the videos, and hopefully you did, on solving series circuits and whatnot. Okay? But you just work this out the whole entire way. V equals IR, V equals IR, V equals IR. It doesn't say there's multiple resistors. It just talks about one. Okay? So these are pretty straightforward.